Number 75. The reaction of carbon monoxide, which is CO, with Cl2 gives phosgene, which is COCl2, a nerve gas that was used in World War I. How exciting. Use the mechanism shown here to complete the following exercises. And then we have a combined total of 3 steps. So we have Cl2 gas coming to equilibrium. I see those double arrows. That always means that it's coming to equilibrium. So Cl2 gas is coming to equilibrium with 2Cl gas. And then step 2, we have carbon monoxide CO plus the Cl gives us COCl. And then COCl plus another Cl gives us COCl2. Now, we have A, B, C, and D. So let's strap in our shoes because we got this. Now for letter A, it just says they want us to write the overall reaction. So what I'll do here is, since we don't have a lot of room, I'll start letter A up top here. Okay, beautiful. Now, if they want us to write the overall reaction, that's the total combined sum of all of the steps in your mechanism. Now, a mechanism might be a scary word, but a mechanism is just something that's basically what I like to think of it as is I like to think of it as a recipe, right? If you ever, baked cookies or baked a cake, you got to follow a certain set of steps, right, in the recipe. Same thing with a mechanism. So the individual steps that they're giving you is the flow of the recipe. So this first step has to happen first, and then this happens, and then this last step. Now, if we want to find the overall reaction, all we have to do is just sum up all the steps. So what I'm going to do is I'm just going to rewrite the 3 steps on, over here, just so that it's easily seeable. So the first step is Cl2. So we'll say Cl2 gas coming to equilibrium with 2 Cls. Okay, beautiful. Then the second step, we have CO plus 1 Cl yields the COCl, and that's a gas. And then we take that COCl gas, and we add another Cl to it, and then we get the phosgene, which is COCl2. Okay. Now, all we're doing is we're taking these 3 steps and just adding them up. So we're going to sum them all together. So what you're going to do is, what you're basically going to focus on is you're going to cancel stuff out that are on opposite sides. And if you have anything that's on the same side, you will add them. So let's see, anything between the left side, it doesn't matter what step it is, 1, 2, or 3, and on the right side that are identical. Well, I see that I have a COCl, right? So we got a COCl here, and then we got another COCl. They're identical. They're both gases, right? So they're both the same compound. So one's on the right, the other one's on the left. They will cancel out. Goodbye. Everything that cancels out does not get written as your overall reaction. So let's see. Anything else that I see? Well, I see that I have just a Cl on the left side, and I have another Cl that's just on the left side. These are identical. Now these are on the same side. They're both on the left side of the yield sign. So collectively, these equal 2 Cl gases, right? So maybe if I just, cancel these out and say, this turns into 2 Cls. But then wait a minute. I have 2 Cls on the right side, and I have the 2 Cls on the left. They're both gases. They're identical. That's ugly. So what are they going to do? You're right. Goodbye. All these cancel. And now let's see. I have Cl2. That's not identical to COCl2, so I can't cancel that out. And then I just have CO. That's not identical to this. So there's literally nothing else that I can cancel out. So we have arrived at our first answer. the overall reaction. So the overall reaction is you just add up everything on the left side and then yield it to everything that's, remaining on the right side. Doesn't matter which one you say first, so I just like to work from top to bottom. So I'll say Cl2 gas plus CO gas, and you could use the general yield sign because it's the overall equation, and that's going to yield, maybe I'll bring this over a little bit, COCl2, and that's a gas. And that is your first answer. So the answer to letter A is Cl2 plus CO yields COCl2. Letter A is done. 1 out of the 4. Now we're going to move on to B. Identify all intermediates. Okay. Now it's great that we did the first step because really by canceling out stuff, that's in your steps, your individual steps for the whole mechanism, you will be able to determine who is your intermediates. Now your intermediates, just remember, is always going to be the ones that are canceled out. So, if you have a substance that's canceled out, chances are it's going to be either an intermediate or a catalyst. Now, just know that the difference between an intermediate and a catalyst, I could probably say, that we don't have any catalysts here because they didn't ask for any, but I'll just put it up here, that an intermediate, just in case it's on your test or quiz, but an intermediate is a substance, compound or a molecule or whatever. It's always going to appear on the product side first, and then on the reactant side in the next step. So for example, do you see here in our mechanism that this one that we canceled out, it was on the product side first, and then to cancel them out, they were on the reactant side. Those are intermediates. So in this case, we definitely have Cl gas. That's definitely an intermediate. And now there's another substance, the COCl. Is that an intermediate as well? Well, let's see. The first time it comes up is in step 2. It was a product. Intermediates are always going to be the products first, and then they come back to cancel on the reactants. So this would also be a intermediate. So COCl. And that's the answer for part B. So you got 2 intermediates here, Cl gas and the COCl gas. Now just to put it up here, that if you were talking about a catalyst, the catalysts are opposite because they will always rejuvenate. So they will be on the reactant side first, and then in the next step, it will be the products. So just know the difference between seeing an intermediate and seeing a catalyst. They didn't give us any catalysts here, so we're good to go with that. Both of these, the CLs and the COCl, was an intermediate. And B is done. 50% of the question is done already. Whoop, whoop. Now, let's go for letter C. So just to recap, that letter B is these. I didn't write down, letter B over here. Because here, now we need room for letter C. Letter C says we have to write out the rate law for each elementary reaction. Now we know what the general rate law formula is, right? Especially if they do say that they're for elementary reactions. Rate laws for elementary reactions is this right here. Maybe I'll make this a little bit smaller. But the general formula for any rate law for any elementary reaction is rate equals K times those concentration of the reactants raised to their coefficients. Keep in mind that you are only allowed to use coefficients if the steps are elementary. And just know that always, every single time, if they give you a mechanism, if they give you that recipe, every single step, so in this case you got 3 steps, every step is classified as its own elementary step or elementary reaction. So we will be able to take those coefficients. So now, let's start off with, I guess, it doesn't really matter. I guess we'll start from top to bottom. So we'll say step 1. Okay, so what is the rate law for step 1? Now in step 1, the reaction is Cl2 gas comes to equilibrium with 2 Cl gas. Now, this one is a little bit tricky because I see a double arrow, which means that basically for this one general equilibrium equation, you have technically 2 reactions. Because just as the Cl2 gas can convert into 2 Cl gases, at the same time, you can go in the reverse direction. That's what these double arrows mean, so that you can have a forward and a reverse reaction. So you can have the 2 Cl's going towards the Cl2. And because you have this double arrow, technically you have 2 individual rate laws. Now they do say specifically that we have a K1 that's representing the rate constant, the K. So we have K1 is the forward rate constant. So we have to state that somewhere. And then K -1, usually -1 means the reverse, is going to be used for the reverse rate constant. So let's work with this one. Now for this step, it's going to be rate equals, I'm just following the guidelines of any rate law, rate equals K. Now since this is the forward reaction, we have to use K1. So this would be rate equals K1 times the concentration of the reactants. So in this case, you only got one reactant, right? You only got the Cl2. And that's that. So maybe we could say rate 1 equals K1. I don't know. Doesn't really matter to me. But now we just got to do the other one, right? So here we go. Rate equals, this one is the reverse. So they did say that for the reverse reaction, we have to use K to the -1. And maybe I'll put rate to the -1 here. And now this is times by the concentration of the reactants. Now I have the reactant of just Cl, but I can use my coefficients. There are 2 of them. So I use my coefficients. This will be raised to the second. And this is your 2 rate laws for the first step. Now we have 2 more steps to go. So let's do step 2. Step 2. That one was CO gas plus Cl gas yields Cl gas. Now, it's only a forward reaction, and in this case, they said that it's slow, right? And it's known as K2 is the rate constant. There's only one K. So, let's go for it. So in this case, we would have rate equals the rate constant, which is K. In this case, we have to denote it as 2 because it's the second step, times by the concentration of the reactants. In this case, now we have 2 reactants. So we have 2 brackets. Beautiful. And the 2 brackets are CO times Cl. They both have a 1 in front of them as a coefficient, which means that you raise them to the first, but anything raised to the first is itself. So we'll just say that this is rate 2. And here is the third rate law out of the bunch. Now we have one more to go. We have step number 3, which was Cl, and I'm running out of room here, but we will fix this up once this one is over. Yield COCl2 gas. They say for this one, we're going to use K3 as the rate constant. So same exact idea. It's only one arrow, which means that you're only going in the forward direction. So we'll say rate equals K, and we denote it as K3. The reactants here are COCl and Cl, so I got 2 of them. So we'll do double things. COCl. Oh boy. Can I fit it? COCl and just the Cl. And that is your fourth total rate law. So we have 4 total. We have the 2 for the reversible equilibrium reaction. We got the 1 for the second, and then the 1 for the third. And I noticed that this needs a 3 here. So rate 3 equals K3. And then we are done with part C. Okay. Last part, letter D. Now we have to write the overall rate law expression. Now, if they're asking for the overall rate law expression, that means that it's got to come from the overall reaction. Okay. So, before we do this, let's pause the video for a little bit. I'm just going to clean stuff up, so if you do need to write anything, I highly recommend you write it now because it's going bye-bye. So, for example, all this work to get us to the overall reaction is going bye-bye. So, just to kind of... Where'd that go? Magic. That's from a specific movie, and I know it's only one word, but it's one of my favorite movies, and without giving too much away, it's like probably late 90s, maybe early 2000s. I would probably say maybe definitely 90s. And he had a really cool car. I think it was a green. It was definitely green. He had a TV show, a green Mini Cooper. So he only had one name basically. But let me know if you know who I'm talking about. TV show, movie. The actor that plays him is known for this role. One of my favorite actors, great comedy actor. But yeah, anyway, let's keep going. So we're going to get rid of this. And, okay, maybe I'll throw this up. Oh boy. We'll throw this up. This is the answer to A. This is the overall. Okay, beautiful. And then I think, let's see. We need to make some room. So if I can, maybe what I'll do is I'm going to get rid of this information because all we need to answer D is the rate laws for each individual step. So I'm just going to kind of clean this up a little bit. I hope I can. Let's see. Beautiful. Here's step 2. There's one more for step 3. Okay. And then, oh boy, this is like a magic act. Magic. Oh man. But basically, the movie that I'm talking about while I'm doing this, to kind of give you more of a hint, is he's visiting a family on holiday, and something about how he has to he has to he meets this painting and he loves the painting and he sits and look at the painting, but then he accidentally messes up the painting. And that's basically the whole movie. I don't know. I love it. But anyway, okay. So, yes. Now we're going to do letter D. And as I'm thinking of the movie, I might be going in and out of an English accent. So I apologize for that. But it might be more appeasing. I don't know. Anyway. All right. So, write the overall rate law expression. So now, generally speaking, is... usually, all the time, you always write your rate law from the slow step. So wherever the slow step is, you find it and you take that rate law. Now, in this case, they told us that the second step was the slow step, right? So what I'm going to do is, since the second step was the slow step, I'm going to take that as the rate law. We always start from there. So in this case, our overall rate law starts always from the slow step, And that's the second step in this case. So I'm just going to say rate 2 equals K2 times the concentration of CO times Cl. All right, now, we cross our fingers because if we were done, we need to make sure that there are no intermediates in our rate law. Now, we did state that there were two intermediates. There was a Cl and a COCl. Do we have an intermediate in our generalized rate law coming from the slow step? Yes, we do. This is the issue. The issue is the Cl. The Cl gas is an intermediate. Boo-hoo, we do not want intermediates ever in our rate law. So, what we're going to do, oh boy, there it comes out. Sorry, guys. But you might know me by now. I'm a little bit, you know, I guess colorful. Not colorful? That's not really the right word. But anyway, funky? Maybe. So we don't want any intermediates in our rate law. So what you're always going to do is, in order to cancel this out, you need to find the fast equilibrium reaction to substitute in for this intermediate. And it's always going to be the fast intermediate one, because they're reversible. So the fast intermediate, right, the one that was really fast, the double arrow one, was the first step. And here is that Cl that we can use to plug in. But now you have two rates. But remember, at equilibrium, the whole idea at equilibrium is that the forward rate equals the reversed rate. So if I know that the forward rate, which was rate 1, equals the reverse rate, which is rate number 1, negative 1, well, rate 1 equaled K1 times Cl2, and rate negative 1 equals K negative 1, Cl2 squared, or Cl squared. So now I'm just going to substitute. The rate 1 is equal to K1, and the rate negative 1 is equal to K negative 1, times the concentration of, in this case, they're both just 1, and we have Cl2, and then Cl. This one was squared, and this is now equal, because the rates are equal. So remember that the object of the game is you want to substitute this out. So sub this out. So what do you think we're going to be solving for in this equation? The one that we want to substitute out, right? So we want to solve for concentration of Cl. Always solve for your intermediate. So how do I get this by itself? Well, the first thing I'll do is I'll divide by K negative 1 by itself, right, on both sides, because you don't want the K negative 1, so this goes bye-bye. And we'll do this a little slow, because once you start getting into like theory with no numbers, it can get a little hairy. But I got you guys. So no numbers, that's okay. This is K1 times the concentration over, we'll put the K2 on the bottom, or K negative 1. And this is Cl2. And this all equals now the concentration of that intermediate, the Cl, and that's squared. We're almost there. We just want Cl by itself. So what are we going to do? It's being squared, so we have to undo it. And you're exactly right. We have to take the square root. And if you take the square root of one side, which will cancel, you take the square root of the other side. So in essence, if I can, oh boy. It's a little crunched, but we're making do. This I'm going to bring up. So So now what we have is the square root equal to, that's Cl, and this is K1 over K negative 1 times by the Cl2. Okay. Now, pause the video if you need to. The only thing that we need now is this. We don't need the math anymore. So what I'm going to do, because I just don't have any room, is I'm going to just erase all of this work. So if you do need it, please copy it down. But it's got to go. Bye-bye. But at least we did it together, just to know where we're going. Because here is the Cl. That's the intermediate. And we want to sub out, remember the whole point of this was we wanted to sub out that intermediate and plop that in. So basically now all of this is going in to that space. So let's give it a shot. Everything else here is going to remain the same. So rate 2 equals K2 times the concentration of CO. We don't do anything with that because that wasn't the one that we were trying to sub out. But now this is basically coming out. So if I can, right? This is coming out. Pretend that that's leaving. And this is now going in its spot. So if you want, you could do like big parentheses. Because the whole thing, the whole square root of K1, whoop, we need this in blue and the other one in red, K1 times K negative 1, and that's it. That is your final answer. It is in theory, because we have no numbers, but this would be the overall rate law expression. So just make sure, basically we had to do this whole thing because you take the rate law of the slow step was the second step, always check for intermediates. Since the Cl was an intermediate, you had to sub it out. And you could only sub it out by using your rate law of the one that's at equilibrium, the double arrow. Don't use this one, because if you've noticed, this also has another intermediate as well, so couldn't use that one. But that is the end of the game. Or not the end of the game, but the end of the question. So, whoop whoop, we did it. All right, what'd you think? I hope this helped you out. Let me know in the comments, and if you're still here at the end, thank you so much for being here. You guys absolutely rock. Thank you so much for supporting the channel. We wouldn't be here without you guys. And new things are coming. So thank you so much for your faith in us, and we won't let you down. All right. So I look forward to teaching you new stuff, and I will talk to you soon. Okay. Have an awesome day. Always have an awesome, awesome, awesome day. And I'll see you later. Bye-bye.